is video 6.3, and in this video, our learning target is I can find areas of polygons by composing and decomposing shapes. If you're not quite sure what that means, basically creating and breaking apart different shapes. The essential question, how do you find the area of an irregular shape? An irregular shape is what we call a shape that doesn't meet the typical square, rectangle, triangle format. Our math practice standards in this video are 1, 2, and 3. And we have several key terms. If you'll look below, area, which is the amount of space inside a figure. Hypotenuse is the longest side of a right triangle. Perimeter is the distance around a figure. And polygon is a closed figure formed by 3 or more line segments. Three more terms actually. Rectangles, one you should be familiar with. That is a parallelogram with 4 right angles. A regular polygon, which is a very important term in this next unit. And that's a figure with all angles and sides equivalent. When it says it's regular, that means everything is the same. And a triangle is a 3-sided polygon. We're going to take a look at some formulas that are going to come in handy for us in this lesson. Rectangle, there are 2 formulas you could use. They basically are the exact same thing. They just use different lettering. Area is equal to L times W, where L is the length and W is the width. Or A equals B times H, where B is the base and H is the height. A square, there are 3 formulas we can use. Again, since a square can be classified as a rectangle, we can use the same 2 formulas that we saw in the rectangles. Or you can use this third one. This is the one I like to use a lot. Area is equal to S squared. Since a square has all sides that are the same, if you're multiplying the same number times itself, you're simply squaring it. So there's another way where S is equal to the side. And finally, a triangle. And there are 2 ways you can look at the formula for triangle. You can use this setup, which is what I typically use, 1/2 times base times height. Now remember, you don't see the dots or the X's or the stars or parentheses that would mean multiply, because we also know that any variables that are side by side or a number and a variable side by side also means to multiply. Or I can write it how some of you may have used it before. Area is equal to base times the height, all divided by 2. We're going to go into our examples, and we actually have 4 examples here underneath example 1. The first one, for all of them, we're going to find the area of each of these. The first one, we have a triangle, and it is a right triangle, and I wanted to do this so that you could see where a hypotenuse would be located. And the hypotenuse is this long side right here. It is opposite the right angle, and the right angle is indicated using a square. To find the area of this triangle, I'm going to use my formula. And you should always write down the formula first. That way you know exactly which one you're working with. I will know if you're using the right one. And you'll know what you need to substitute in. The second step would be to substitute in the information. So I have 1/2 times, the base is 10, the height is 4, and now I'm left to do nothing more than solve. In this problem, the way I like to do these, sometimes you've got an easy multiplication problem here and something easy to take half of. But if you don't, look at your 2 numbers given. Decide for yourself which one is the easiest for you to take half of, and then multiply times the other one. In this case, you could take half of 10, which is 5, multiply 5 times 4, and you get 20. So the area of our shape is 20, and we were measuring in meters, so I have to have the M for meters, and it is always square units. Moving on to picture B, we have a rectangle. So you can use any of those 2 formulas. I like to use base times height because I use base times height in my triangles, and they are related. The area is then equal to the base, which is 25, times the height, which is 6, and our area is 150, and we're in centimeters, centimeters squared. Moving on to our third shape, and here you know this is a square, and the reason I know it is because I've been given one dimension. If I'm not given any other dimensions, I'm to assume that this is all these sides are the same. Sometimes you might even see it done like this, which means that that symbol indicates that all sides are the same. So our area is equal to, and here's the one I like to use, side squared. Area is equal to our side, which is 8, squared. This brings back in those exponents, which you learned about quite a few units ago. And then our area is equal to 8 squared, which remember is not 8 times 2, it is 8 times 8. And that would be 64 inches squared. Now, look at D. Some of you may look at D and say to yourself, oh, I know what that shape is. That's a trapezoid. And there is a specific formula for trapezoid. But for this particular lesson, I don't want you to think of this as a trapezoid. What I want you to think of this as is a shape made up of two different shapes. Here's where we are decomposing a shape, a polygon, to find the area. We have a rectangle and a triangle. Now, what we need to do is we need to fill in some information. This side of the triangle and this side of the rectangle are the same, and if you can see, they share a side. So this side would be 5. So the height of my triangle, is 5 meters. Now I need to figure out what is the base of my triangle. I know that this side of the rectangle is 7, and I know from this end of the shape to this end is 12. And this 12 includes the 7 for the rectangle and whatever the length of my base is for my triangle. To figure out what this piece is, you are going to subtract these two dimensions. 12 minus 7 is 5. So the base of my triangle is also 5 meters. Now, to find the area of this figure, I'm going to look at this as figure 1, figure 2. Find the area of each of these figures, and then you're going to add them together. So the area of figure 1, the base is 7, the height is 5, so my area is 35 meters squared for shape 1. Go to shape 2. Shape 2 is a triangle, so I'm going to use 1/2 base times height, and the base is 5, and the height is 5. Now I don't have nice numbers here to multiply and divide in half, but for me it's easier to multiply 5 times 5, which is 25, and think about what is half of 25. And in this case, the area here would be 12 5/10, or 12.5 meters squared. Now we're almost finished. We have to add shape 1 to shape 2. So 35 plus 12.5, or 12 5/10. So our total area of the whole shape is going to end up being 47 5/10 meters squared. Now we have 2 more examples. My board took off some of the print. I hope you can still read it. Example 2 says that my backyard is a rectangle. It took 600 feet of fence to enclose the backyard. And when I say enclose, I mean put it all the way around. The length of my yard is twice as long as the width. What are the dimensions of my yard? The dimensions, that word means basically what is the base, what is the height, what is the length, what is the width. What I suggest you do, until you get really comfortable with problems like this, draw a picture. So if this is my backyard, and I know that all the way around my backyard it took me 600 feet of fence to fill that in, that's the perimeter of my yard. And that comes from adding each of these sides together. If I start adding, I know I have to come up with 600. So you might want to start and say, okay, well, what if this is 100, 100, 100, 100? That only gives me 400. I'm short 200. But the clue in the problem says that the length is twice as long as the width. So if this is 100, 2 times this would be 200. So if the length and the width of my rectangle backyard are 200 and 100, if I add them all up, I will get the 600 feet that it took to enclose my backyard. So the dimensions, length is 200 feet, width is 100 feet. And you'll notice when we talked about the perimeter, we didn't square anything. We're not looking at the area, we're looking at the perimeter. Let's go to example 3. Mrs. Myers has a square yard. Its area is 25 meters squared. She needs a fence around it for her dog. How long will the fence need to be? You know the area. We need to go around her yard, so we need to find its perimeter. So if I, again, draw a picture, and I know that the inside here is 25 meters squared. If it's a square, I know that the sides have to be the same length. So in my mind, I need to ask myself, what times itself gives me 25? That happens to be 5. So I know that each of the sides of her yard are 5 meters. And I can then add her sides of her yard together, or, since they're all the same, multiply 4 times 5, and I will get 20 meters. And that is how long her fence would need to be.